Good morning. So today I'm going to tell you about flip-flops. So first, before going to flip-flop, you should know what is sequential circuit. Flip-flop is a sequential circuit. So sequential is made up with combinational logic. So combinational logic is like it's a combination of gates which can perform operations like add, subtract, multiply. And it only depends on current input. It does not depend on like memory. It does not depend on past value or futuristic value. But in sequential circuit, it depends on current value as well as past value, which is already stored in that. So that is why it is called as memory bit. Now, how I can differ in terms of block diagram. So in the block diagram, sequential circuit is a combination of combinational circuit plus storage element. So this storage element is nothing but flip-flop, which can store a single bit of information. And input is given to combinational circuit. This combinational circuit is made up with combination of gates. And its one part is going to storage element. Storage element input is next state of any flip-flop. And the present state again going to the combinational state. So based on combinational state as well as the present state of storage element will decide the next state of flip-flop, and that will consider as the output of flip-flop. And these states are called as time states. So this is a block diagram of sequential circuit, which is nothing but combinational circuit plus some storage element. As I said, sequential circuit is having feedback element. Feedback element is done with the help of some wire, so that provides you some delay also. That delay is called as key delay or wire delay, and it depends on past inputs as well as past circuit state. And the memory element is required in that. That memory element is called as flip-flop, that used to store the information. Now there are basically two types of sequential circuit. One is synchronous, another is asynchronous. As the name said, synchronous sequential circuit means entire output depends on certain time interval. So it changes with discrete time interval. That discrete time is nothing but clock pulse. So it entirely depends on clock pulse. So once the clock will come, entire output will change. Then next output will change with the next clock pulse. So it's a discrete time instant it is changing. But in asynchronous, it does not depend on clock pulses. It can change as your input is changing or as the things are changing, and immediately at that time only output will change. So that type of circuit is called as asynchronous. Generally asynchronous is latch and synchronous is called as clocked flip-flop. Now this is the clock signal. Clock signal is nothing but a periodic signal, or it's a train of pulses which is separated, its time interval is t. It's a square pulse, right? It can be this is one is showing square pulse and this one is showing a pulse waveform, right? So two pulses are there with different duty cycle. Now, as I already explained, in the synchronous circuit, this is a synchronous sequential circuit in which clock pulse is there. So this flip-flop is having two inputs. One is clock pulse, another is coming from combinational circuit. So it depends on timing diagram or clock pulses. Now what is flip-flop? So flip-flop is the device which can store one bit of information, right? So it can maintain its state as in terms of input pulses. Now what is memory? So if I define memory, that should have three properties. It should be able to hold a value, first of all. It should be able to read the value, and the value whatever is stored should be able to change. This is what is the three characteristics which we are looking for a memory. The flip-flop which we are using is 1 bit bistable memory. Now what is bistable memory? So bistable memory is saying that it is having two possible outputs, and both outputs are stable output. So two possible stable output is present in any flip-flop. You can read the bit in that and you can save the bit in the flip-flop. Here two inputs are mainly used. One is set, another is reset. Set is to set the bit, reset or clear to make it 0. So this is called as S and this one is called as R. These are the two things which is used generally for any flip-flop, R and S. Right? Now there are two types of flip-flop again based on their clock pulses. One is called as level triggered, another is called as edge triggered. So level triggered, as you can see in the clock pulse, these are the levels. It can have positive level or it can be negative level. And these are the edges. This is a positive edge and this one is the negative edge. Negative edge means when it is going from high to low. And positive edge means it is going from low to high. So your flip-flop can be positive edge triggered, can be negative edge triggered. So this means whenever positive edge will come, your output will change or response will change. And if I'm taking a positive level triggered, that means whenever positive level will come, in that positive level also I have to decide a point where my output is changing or where my circuit is responding. So according to that we can select. Right? This is a negative edge, this one is positive edge and this is a level triggered. Now here is the basic diagram of SR flip-flop latch. SR is S stand for set, R stand for reset. And these are the two NOR gates. This is a combination which makes a flip-flop. And this is latch. Latch means which is not having clock pulse is called as latch. Now here you can see one feedback is coming from Q. Q is the output. Q bar is complement of Q, which is a complement of your output. So one feedback is coming from Q to one NOR gate. Let's say this is NOR gate number 1 and this is NOR gate number 2. So one gate is getting Q bar, inputs are Q bar and R. Gate number 2 is having inputs are Q and S. So here is the functional table. I'll explain this functional table one by one. I'll explain. Now I'll consider all the inputs. By considering S and R 0 condition, I have to check what value of output I'll get. So let's assume with the help of this diagram, let's say S and R both are 0, 0. So S 0 and R 0 both are 0, 0. Now let's assume Q is 0. Q equals to 0. Let's assume this. Right, so Q bar will be equals to 1. This is what will be there. Now this is gate number 1 and this is gate number 2. Right, now what will happen? I have to check outputs of gate number 1 and gate number 2 and according to that I have to decide. It will be my final output. So here R is 0 and this Q bar is 1. So both the input of this gate number 1 is 0 and 1. And this is a NOR gate. If any one of the input is 1, my output will be 0. So that means Q was 0 and it remains 0. Now the 0 input is going to gate number 2. So in gate number 2, both my inputs are 0, 0. So gate number 2 output will be 1. Because with NOR gate, both inputs are 0 gives me output as 1. So I checked all the combinations, entire combinations, and I come to know that I assumed Q was 0 and I am getting Q as 1. Q bar as 1 and Q. I am getting the same value when S and R both are 0, 0. I can try out with Q is equals to 1 and Q bar is equals to 0. Again the condition will remain same. Means if I'll assume Q is equals to 1 and Q bar is equals to 0, it will give me same values. So that is why you can assume this circuit is more clear. This diagram is more clear. Here it was assumed. So we had checked this condition, Q is 0 and Q bar is 1. Now I'll check this condition where Q is 1 and Q bar is 0. Again I'll assume gate number 1 and gate number 2. Right. So for gate number 1, my inputs are 0 and 0. So 0, 0 will give me output as 1. And gate number 2, my inputs are 1 and 0. So this will give me output as 0. So this 1, 0, 0, 0 combination is giving me no change condition. Means whatever previously I assumed Q, same value I am getting. So that is why this SR 0, 0 condition is called as no change condition. Now let's go to another condition where R is 1 and S is 0. So Q is 0 and Q bar is 1. This is what is assumed. Now let's see what will happen. Again, I'll take gate number 1 and gate number 2. So my input for gate number 1 is 1 and 1. So for NOR gate, if both the inputs are 1, my output will be 0. So I'm getting output as 0, which is 0. Now 0 is coming to gate number 2 as input, and second input is also 0. So 0, 0 will give me 1. So I'm getting 0 and 1. Now if I try out with q is equals to 1 and q is equals to 0, my output always will give me 0 value. This condition is called as reset condition. Now next condition I can try out for set condition, where S is 1 and R is 0, and Q is considered as 1 and Q bar is considered as 0. Reverse I can try out. So if I'll try out for gate number 1 and gate number 2, so this gives me 0, 0, output will be 1, and here it is 1, 1, output will be 0. So this condition is called as set condition, and I'll get output as 1. Now last is 1, 1 condition, which is not used in that, because if I'll consider Q is 0, Q bar is 1. So for both the NOR gate inputs are 1, 1. So they will not depend on R and S, both are 1, 1. So they will not depend on previous Q value. I'll get both Q and Q bar as same. As both are complement to each other, they cannot be same. So that is why this condition is called as not acceptable condition. So if I summarize quickly, if I get SR00, my output is QT, which is same as previous value. If I'll get 0, 1, this condition is called as reset condition, so my output is 0. If I'll get 1, 0, then my output is 1. And 1, 1 is not defined condition for SR flip-flop. Now here, the same thing that was latch with NOR gate. Now this is same thing but with clock. Here you can see instead of 2 gates, there are 4 gates. So 2 more gates are connected, gate number 3 and gate number 4, and those are connected to clock pulse, right? So this condition, I have to assume that this condition will only work if clock pulse is present. So if suppose I'll say clock pulse is 0, that means my gate number 3 and 4 will give me output as 1, 1, which is a no change condition for NAND gate latch. So this condition will remain no change and output remains as it is as previous value. If clock pulse is 1, then only my entire circuit will change according to S and R value. Rest of the thing will remain as it is, as we had done in NOR gate condition. So this 1, 1 condition is, CP is 1, then only S and R value will take place. Otherwise it would remain same. So this is entire detailed characteristic table is given, and this one is called as characteristic equation for SR gate. Now same can be done with D gate. In the D gate, D latch, if I consider, S and R both complement to each other. So this is called as D flip-flop, data flip-flop. D stands for data. So D is same as S and R is complement of that. So this will only give me condition 0, 1 and 1, 0. So in that condition, if I just check previous table, this is follow S value only. So if S is 0, that means D is 0, this goes to Q is 0. If D is 1, then Q is 1. So that is why this is called as data flip-flop, because it follows your Q follows the D value. That is why this one is called as data flip-flop. This is the functional table for data flip-flop. Now next part we'll do in next class.